Today we are talking about how to graph quadratics from Vertex Form. Alright, so let's remind ourselves from last semester. For linear equations, we had three graphs. We had y equals mx plus b, standard form, which is just written as a number times x plus the number times y equals another number, and we had point slope. Now we're able to graph from any form, but the easiest way to graph is from y equals mx plus b. Now for quadratics, we have two types of graphs. We have standard form, and we have vertex form. Now just like linear equations, we have one form that's easier to graph, and that is our vertex form. Okay, so go ahead and pause the video and write down the vertex form of a quadratic. Okay, now that you've got that written down, let's figure out what the heck it means. Okay, for now we're going to skip this a term, and we're going to ignore it. We're going to move to this h term. Okay, the h term tells us how far to the right or how far to the left our u is going to shift, because a typical quadratic is going to cross right at 0. But if we have some term next to x, it can shift to the right or to the left. Now the h term is a little bit funky, okay, and this is how I remember it. H is inside of these parentheses. So we think of those parentheses as your house. Now in your house, if you look up, all you see is the ceiling. So you're just going to look to the left and the right. That's how we remember that H goes to the left and the right. But when you're in your house, you do not have to follow social norms. You can do whatever you want. If you want to, you can take all your clothes off and you can get naked and dance around like a crazy person, if you want. Okay, so inside your house, everything is backwards. Okay? Now, when you go outside, like K is, it's outside of your house, you can see the sky. So K tells you how far up or down your parabola is going to go. Now, when you're outside, you want to follow those social norms. You don't want to be too crazy. It would be bad if you danced like a crazy person and took your clothes off. You don't want to do that. So everything outside just responds normally. Okay? So let's see what the heck I'm talking about. Okay? So let's look at this -2. Okay? Our -2 is inside the house, so it's going to be backwards. So we're going to think of it as a +2. Now if we go +2, right and left, we know that's going to shift us to the right 2. Okay, so that's our first transformation. Now we're going to look at our y value. Okay, -3. -3 is outside, so everything is normal. It goes up and down, so we know this tells us to go down 3. So we now have enough information to graph the center of our parabola. So we're going to go to the right 2, down 3. So there's the vertex of our parabola. Now a parabola is just a U. Okay, the most important part of a parabola is the squared. So the way I graph parabolas is I start at my vertex. So I'm going to start right there at my vertex. And I'm going to go out 1. And when I say out 1, I mean I'm going to go to the right and to the left 1. Because a parabola is a U, the same thing happens on both sides. So I go out 1, and I say, what is 1 squared? Well, hopefully you know that 1 squared is 1. So I'm going to go out 1 and up 1. Put a dot here on each side. Okay, but now go back to your vertex. Always go back to your vertex. And now, instead of going out 1, we're going to go out 2. Now, 2 squared is 4. So from my vertex, I'm going to go out 1, 2, and up 1, 2, 3, 4 on both sides. Now, I can keep going forever. I will do it one more time, but after that, we're just going to stop. So I'm going to go back to my vertex. This time, I'm going to go out 3. And I say 3 squared is 9. So I'm going to go out 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9, and do my points. Now, like I said, we can keep going. We can get out 4, go out 5, go out 6, but this is enough to get the general shape, which we see is a nice curvy U. And you have just graphed a quadratic. All right, now I said in this formula, we're going to skip the A, but we're going to come back to A now. Okay? So let's go ahead and look at an example to see what A does. All right, so in this example, everything is the same until we get to the A. So a positive 3 inside is like a negative 3. So this means we're going to shift to the left 3. This positive 1 right here is outside, so it's normal. We're going to go up 1. So those are our two transformations. And we can graph our vertex at the point negative 3, positive 1. Now this is where it gets tricky. Just like before, we're going to go out 1. Say, what is 1 squared? 1 squared is 1. Now we multiply by this a value out front. So positive 1 times negative 2 is negative 2. So I'm going to go out 1, down 2. Out 1, down 2. Okay? Now we're going to do the same thing. We go back to our vertex, and this time we're going to go out 2. Okay? 2 squared is 4. 4 times this negative 2 value is negative 8. So I'm going to go out 1, 2, down 1, 2, 3, 4, 5, 6, 7, 8. Oops. Okay, now I don't really have any room for more points, so I'm just going to go ahead and sketch in my curvy U. And I have another quadratic graph. Okay, so let's fill in our notes. The A value does two things. Number one, it's able to flip the graph if it's a negative value. The second thing, which is a little harder to tell, is it actually makes our typical quadratic that looks like this change weight. So if you look at this one in black compared to the one in green, you see the black one's just a little bit skinnier. Okay, so our A value has the ability to make our graph skinnier or fatter. Okay, and we'll do some examples to see when each of those things will happen. All right. So we've got two examples here that look a little bit odd, but they're actually just the same. Okay, so let's look at this first one. We see that we have a plus 4 inside, so we think of it as a negative 4. So we're going to shift to the left 4. We don't have anything outside, so we're not actually going to move up or down at all. So my vertex just sits right here. Then we continue as normal. We're going to go out 1. 1 squared is 1. 1 times a negative is negative 1, so I'm going to go out 1, down 1. We go back to our vertex. From our vertex, we go out 2. 2 squared is 4, and 4 times a negative gives us a negative 4. So we're going to go out 2, down 1, 2, 3, 4. Now we can sketch in our curvy U. All right, here's our second odd case. In this situation, there's actually no value inside with x, so that means we're not going to shift right or left at all. This plus 3 still shifts our graph up 3. So our vertex occurs at 3. Just like before, we're going to go out 1. When we go out 1, 1 squared is 1. 1 times negative 1/2 is negative 1/2. So we're actually going to go out 1 and down a half of a square. Out 1, down a half of a square. Okay, a little funky. We're going to go back to our vertex. We're going to go out 2. 2 squared is 4. And 4 times the negative half is negative 2. So we're going to go out 2 and down 2. And there is our curvy U. So hopefully you guys see this is a fatter graph than we had in the last example. It's because of our A value. All right, your turn. There are two graphs here. We want you to graph each parabola using both the transformations horizontally, vertically, and that A value, which makes it fat or skinny. Answer the bonus question at the bottom for extra credit. Good luck.